Chemistry is the study of matter and its changes, and it's important that we're all on the same page with what this means. So we'll begin with a review of some of the basic terms and classification schemes associated with matter. In this PowerPoint, we'll define what matter is. So matter encompasses everything that we encounter in our world. It's the food we eat, the beverages we drink, it's the air we breathe, and the molecules and substances that make us and every other living thing up. It's what the objects in our life are made out of, whether they're plastic, metal, wood, or stone. It's the fuels we use to power our world and the substances we use to clean, paint, and create. This is an amazing variety of substances. And all of these different types of matter have two very important characteristics in common. It's these two characteristics that form the basis of our definition of matter. Matter is anything that has mass and volume. So mass is a measure of the amount of matter in a substance. We measure mass by weighing a substance. It's important to note that weight and mass actually aren't the same thing. Technically, weight is a measure of the force of gravity acting on mass. And so weight can vary as the force of gravity varies from one place to another throughout the universe. For example, you have a very different weight on the surface of the moon, where gravity is much less, than you would here on the surface of Earth. Your mass, however, would not necessarily change between the surface of the moon and Earth, because the amount of matter that you represent wouldn't necessarily change. When we measure mass, we use balances that compare the weight of substances to known standard masses. Because the force of gravity is constant for the substances being measured on the balance, their weights are proportional to their masses, or the amount of matter that they contain. If their weights balance, then they have the same mass. That's the principle behind laboratory balance measurements, whether they're made with a simple pan balance, like the one depicted here on the left, or a more complex analytical balance like that pictured on the right. The second defining characteristic of matter is the amount of space it occupies, or its volume. Even gases occupy space. We don't normally see it unless we can contain or capture the gas, as seen in these helium balloons. Another distinguishing feature of all matter is that it can be broken down into tiny particles called atoms and molecules. The individual properties that we observe on the larger macroscopic scale for matter are all directly related to the properties and interactions of these tiny particles. And for the longest time, we couldn't directly observe the existence of these particles, and our understanding of them came completely from indirect evidence. The development of scanning tunneling microscopes, or STMs, in the early 1980s, however, were able to provide us with the first real images of atoms, which is a very exciting development in our ability to see at the microscopic level. So on the right, you see an STM image of the surface of the gold nugget that's depicted on the left. The small spheres that you see in that STM image are the individual atoms of gold. So this image actually represents a magnification of the surface of about 100 million times. And just to give you an idea of how large that magnification really is, if you took a tiny, tiny grain of sand and magnified it 100 million times, it would seem to be almost as big as Mount Everest. So in summary, chemistry is the study of matter and its changes. All matter has mass and volume. Mass is the amount of matter something contains, and volume is a measure of the amount of space that matter occupies. All matter is made up of particles, and the properties of matter on the macroscopic level are determined by the properties and interactions of matter on the particle level.